Okay, in this video, we're going to have some binomial practice. In an Olympic archer is able to hit a bullseye 80% of the time, assuming each shot is independent of others. If he shoots 6 arrows, what is the probability of each of the following results? Now, let's determine what distribution that is. So, since each time he hits the bullseye with 80%, and you only have two outcomes: hit it or you miss it. And each time is independent to other, so that means they satisfy a binomial distribution. Okay, n is equal to the number of trials. In this case, he shoots 6 arrows, and the success rate for him is 80%. So this should be your distribution. His first bullseye comes on the 3rd arrows. So that means this one is a little bit special. We can just use a binomial. We want to use the probability. So the probability that we want the first two is a failure, and then success on the 3rd one. So that means I have, failure should be 0.2. If your success is 0.8, your failure should be 0.2 times 0.2 times 0.8, which is 0.032. Okay, he misses the bullseye at least once. Alright, so that means when he follows the binomial distribution and he missed the at least once. Okay, so how do we interpret this? So in here, the binomial success, that means he hit the bullseye is 80%, right? So that means he missed the bullseye. There's 20% of the chance that he will miss the bullseye. So now we're looking for the miss. So the miss is actually our success rate. So the binomial distribution should be with 6 trials. The success rate in here, because we're looking for his missing bullseyes. So this should be, instead of 0.8, we should change that to 0.2. Should be 20%. That's what we're looking for. Again, the success and failure is a relatively concept. Success is what we are looking for. In this particular question, we're looking for his missing bullseye rate. So that's why the success rate should consider as 0.2. Okay, so that means P at least once. So that means X is greater than or equal to 1. Now, let's use GeoGebra. In GeoGebra, you want to change the trial become 6, and then the success rate should be 0.2, and then at least 1, so that means X is greater than or equals to 1. So that means the probability is going to be 0.7379. So this is very important for you to how to set up the binomial distribution. That's why I want each time when you're doing the binomial distribution practice, you need to write down what does X mean. In here, X is the missing bullseye rate. So that's why in here should be 0.2 instead of 0.8. Next one is he gets exactly 4 bullseyes. So in X should be binomial distribution, since we're looking for the success. So X as the random variable is looking for success. The success should be 80%. So exactly 4 bullseyes should be when the probability X equals to 4. In here, we want to change the P to 8. And then X is between 4, or we can just type in 4, or just look in here 4, which is 0.2458. Okay, now he gets at least 4 bull eyes. So that means still binomial distribution with 6 trials, the success rate is 80% because we want to see he gets the bull eyes. It's 80%. At least 4, which is greater than or equals to 4. Now, GeoGebra. And here we have s greater than or equals to 4. Oops, the other way. And you can also check your answer by look at the graph. See where is the highlighted part, because you know that at least 4 you have either x equal to 4, x equal to 5, he gets 5 bull eyes, or all 6 bull eyes. So that means when you look at the highlighted part, you will expect it, okay, that should be the result, which is 90%. Sorry, it's my dog.